In this video, we will use what we learned so far in order to build our own monad from the very basics. And before we start, remember that all the code of this course is present on github/michelenucci/Plutus oriented Haskell, and here you'll find all the code of the course. And of course, the exercises of this video are in the exercises folder under the 2D monads folder, and here you'll find the exercises of this video. So back to the program, the first thing that we need in order to have a proper monad instance is to have a functor. And before illustrate the exercise, let me show you what we are going to work with. In fact, during all this video, we will be working with what is defined here. And well, you'll see that I have defined a data type that I called logger, and this logger is parameterized with two types. Therefore, the kind of the logger is something like this, and the purpose of this logger data type is to wrap an array of messages that can be of any type together with a value, and this value can be anything. And of course, the main type for the messages usually will be strings. So I also defined a type alias that I called string logger. And well, a string logger is something of kind from a type to an entirely new type, since it does have only one parameter, and this is the data type that we'll use in order to build our own monad. I do have also already defined an instance for show, so that when we'll check how our logger is doing, we'll have a nice interface with the value he's holding and the messages he has got up until that moment. And then I have also defined an utility function that is creating a new logger that does not really hold any real value. In fact, these two parentheses are a special value that we never encountered until now, only because this is actually a useless value. Well, as we see, these parentheses are used as a value here, and we see that the type of these parentheses are the parentheses themselves. So we can ask for the kind of the parentheses, and we see that it's just a normal type. And if we are not satisfied, we can ask for information about the parentheses, and we'll see that are a data type with only one constructor that does not take any kind of value. Therefore, represents a data type that can only have one single value, and that is also why we do not really use this value from the moment that until now we only work with pure functions. So those functions were useful only if those returned something. In this case, this log message is only used in order to have these side effects, but we'll see how this function turns useful even if the returned type is just a useless value. So now that we introduce what we are working with, we know that this is the data type that will be our monad. This is just a way to print it, and this is a utility function that will allow us to have side effects. And with that, we can start writing our first instance. As we know, every monad is an applicative, and every applicative is a functor. So we'll start by implementing a functor of the logger with whatever type that we can log. And since we are implementing a functor, remember that the functors are just meant to be generic container on which we can apply generic functions on the values they contains. And in the case of the logger, the fmap function is supposed to act on this value. And since this is meant to be the container, fmap does not touch the container. So you should have everything you need in order to implement the fmap function for a logger container. Therefore, pause the video and try to solve the exercise. Alright, I hope you were able to solve the exercise. In any case, I'm going to show you my solution, which is the one that you can read here. And my solution was just to deconstruct the logger we got using pattern matching in order to extract the value and then return a logger with whatever messages were present in the first logger, since of course we are not touching the container and the messages are meant to be part of the container, and applying the function we got only to the value as fmap is meant to do. And of course we can test this. We see that fmap works just fine and it does not touch the messages, as of course is meant to be, and well, it works also with the operator, since there is of course no difference. So with that, we can pass to implement an instance of the applicative type class for our logger. And if you remember, the minimal functions that we'll need in order to have an applicative are the pure function, which given a plain Haskell value should return that value wrapped into the container without side effects, and then the apply operator, which as we know is similar to the fmap operator, with the difference that the function we got is wrapped into a logger. And remember that applicatives can handle side effects, and this is done right here. In fact, in the case the container of the function does have any side effects, in our case messages, those should be handled by the apply on top of course, applying the function to whatever value we have. And with our logger, for simplicity, we assume that this array of messages is working as a stack. So each time we have a new message is added on the top of the stack, therefore at the beginning of the list, and older messages will stay on the bottom, therefore at the end of the list. So with this information, you should be able to implement the pure function that lifts a value into the logger context, and the apply operator that applies a function already in the context to a value already in the context and takes care of potential side effects. So pause the video and implement the applicative instance. Alright, I hope you implemented correctly the applicative instance for a logger, and if you did, well, now we have something cool to play with. So this is my solution. The pure function is really straightforward. It takes the value and returns a new logger with no messages, of course, since this is the pure function, and whatever value we got inside this logger. And then I have implemented the apply operator, which deconstruct the function in order to extract any messages that happened before, and also extract the function that we'll use. And I also deconstruct the value in order to both get the new messages and the value to provide to the function. And then the implementation is just constructing an entirely new logger with the new messages added before the func messages, and then the value held by this logger with these messages, which is our container, will be whatever is the result of the function applied to the value. And notice how by doing this, we are having a side effect. In fact, the pure function would have been just to, of course, apply the function to the value, but no matter what is the function or what is the value, we will add new messages to the old messages, and this is our side effect. And this is also hidden to the end user, which will use our logger monad, or well, applicative until now, since the logger together with the messages is our container, and in the case of an applicative, our logger with our messages is also our context. And we can see how these side effects are happening as an example with this little expression. In fact, remember that const is a function that takes two arguments, therefore we have to provide two arguments in order to evaluate the const function. And remember that const provided with two values returns always the first, no matter what is the second value. But we see that with applicatives, something different happens. In fact, well, we can fmap the const function to a value of 2 lifted into the logger context, and being a valid function, we can use the apply operator with another value wrapped into a logger, and we see that, well, const is doing its job. But if the second logger happens to have some messages, even if the return value will be totally ignored, the side effects will happen in any case. And we see that we have logged an hello world string into our logger, which is holding our 2. And well, we do have an utility function that allows us to create a new logger with new messages, and we don't really care about the value that is holding. And by using this utility function, we can write an expression like this one, where, well, yes, we do have a chew as a value, but we are able to have the side effect of logging a message, and we see that we have successfully implemented some side effects into the const function, and we did this in a purely functional way, just hidden to the end user, since the context is handled by the apply operator in this case, without the need from the user to do anything else than applying the function to the value. And with that, we can pass to implementing a monad instance for our logger. And well, remember that a monad has to have 3 functions, but only one is needed to be implemented when creating a new instance of a monad, and the other 2 are derived. In any case, I made explicit this derivation just by implementing the return to be the pure function that we defined into the applicative, and implementing the sequence operator in terms of the bind operator that you should implement. And remember that the bind operator is something that, given a monad, in our case a logger, and a function that unwraps whatever value was in the previous monad, and based on that value returns a monad with potentially a new value. And as for the applicatives, the bind operator is responsible for handling the side effects. So with this, you should have all the information needed in order to implement a bind operator for our logger monad. So please now stop the video and try to implement this instance yourself. Alright, I hope your monad instance is working properly. In any case, I'm going to show you my solution. And here we have it. Well, of course, the sequence and the return have not changed, but this is the implementation of the bind operator, which works by deconstructing the first monad in order to extract both the hold messages and the value that we'll need. And well, we know that here we should have a function, so there is nothing to deconstruct. And then I am using a let-in construct in order to first create the new monad logger based on the first value provided to whatever function we got. And I'm doing that in order to extract the new messages and what will be the return value that will be wrapped inside our logger context, and then using what we got from this deconstruction and this deconstruction in order to return a new logger that holds the computed value by the function and handles the side effects by adding any potential new message on top of the old messages that we had in the previous monad. And we can, of course, test this, and in order to do that, here I have an expression that, well, takes a chew and lifts it into whatever applicative context, in this case, of course, the logger context, and binds these two inside this function, and inside we have a log message that logs a string, and then we have the sequence operator that will return, as we see here, this value, but is using the bind, therefore is keeping this message as an effect. And then at the end, this return, as we know, just wraps this new value inside the logger, but gives us the feeling of being in an imperative language. And we see that this expression works just fine. And with that, we successfully implemented a container that is keeping track of a context and is able to have side effects that are working with that context, and at the same time is able to holding values in order to construct computations. So I hope this video was useful to you. If that was the case, consider to subscribe to the channel. And in any case, I want to thank you for your time. Remember to stay decentralized, and I will see you in another video. Bye bye.